You're welcome to this training. This training is titled How to Use Social Network Analysis to Improve Business Profit. The training is brought to you by INF Network Solution. All our past trainings free. They are on our YouTube channel, so you might want to check that out. And if you have any question on the training, that's this training or the previous ones on our channel, you can call 081 800 83821. We also have a group on Telegram, that's Data Science for Business Virtual Club. So if you have any issue with the training, maybe you have a question, maybe you have some errors and all that, you can post it on the group and then we'll send you the corrections. We'll tell you how to go about solving the problem. If you want to be a part of the group and you're not a member already, you can send your WhatsApp number to the same number I just mentioned and we'll send you an invite. Then for the software, for the training, for example, we use free and open source softwares that you can easily download online. And that's our RapidMiner, gephi, and so on. So you can find the video of how to go about installing any of the softwares that you need on our channel too. And if, for example, though you can use any data to try out the tutorial, but if you want to use the exact data that we used, you can also send an email to the same number, and we will send you the link to download the exact data that we use for the training. So, but if you want, you can use other data. So our goal in this training is to use social network analysis to improve business profit. And though we are using a problem scenario here that has to do with community bank and all that, but I would like to let you know that you can actually use any problem scenario, and then you can use any social media platform apart from the one that we used in this training. But we just picked an example, a case study, so that we would run through it and you'll be able to have an understanding of what is going on. So for this training, we want to use a problem scenario that has to do, for example, maybe a startup community bank wants to do a market research in order to generate insights for more profits and all that. And they have started to use the Twitter platform, and which will be the data source. So in order to do that, they want to use some search criteria. Maybe it was around the COVID era, and of course, the bank is in Nigeria. So they use this search criteria, bank, COVID, and Nigeria. So you can use any search criteria depending on the kind of thing that you're interested in. So from the data that they get from this Twitter, they now want to create a network, which is what I have here where my mouse is right now. And from this network, they want to find major influencers, okay, on that particular social network platform. And what can they use this to do? They can use it to, do some strategic marketing for more profit. Then they can also use it for competitive intelligence analysis. For example, they want to look at some of their competitors and find out what they are doing so that they can, position themselves better. So that is our goal in this training. So we'll look at theories, for some theories like we always do. We want to see what exactly are the fundamental theories behind the social network analysis. Then we'll look at the Netlytic, which will be our data retrieval platform. Then we'll do some analysis in gephi and, apply all this to the goal that we set out to discover or to solve that I just explained now. So these are the materials that you're going to be needing. Of course, you need the internet connection, particularly because of the Netlytics, to be able to download the data. They will be using the gephi software. And like I said, the data will be downloaded along the way. So networks, what exactly are networks? So we said network are set of objects and that are connected with edges. So this is a network, for example. It has some objects and then it has, links between these objects. There are different types of network. We have social network. For social network, maybe on the social media, for example, this is a network of BBC News sharing community on Twitter. Then we can also have co-authorship network, which is what I have here, how people are collaborating to be able to do research. Then we have transportation network, information network, biological network, and so many more. What do we use this network to do? These are some of the applications, or these are some of the inferences that we can make from different types of network. For example, maybe in a social network or social media network, you might want to look at how is rumor likely to spread, and you might want to cash in on that for some, benefit. Then we might want to find out who are the most influential people in a particular organization. And in a social network, you might want to know if a network is likely to split, and if it splits, who is going with who. Then in a transportation network, for example, maybe you might not want to know which airport is has the highest risk for virus spread, and then you want to put some measures in place. You might want to see which part of the world is highest to reach. Maybe there's a natural disaster, and so on and so forth. So these are some of the things that you can actually find out in network. So let's look at some network vocabulary. For example, we have what we call nodes. Okay, nodes can be people, it can be departments, it can be any object, transport station that you can actually, want to study. Then you have the edges. Edges are the links between these nodes, between these objects. So, and these edges can be weighed. Okay, for example, if you have an email network of people in a particular organization, the number of email that is going back and forth between two different nodes, for example, can be, can be represented by the thickness of that link between them. So that's a way to actually reflect maybe the width of the edges. Now, we have different types of network. We have the bidirected, and for that bidirected, it simply means that you have a back and forth communication or link between the objects in this network. For example, if IBK is connected to Kunle, and Kunle must also be connected to IBK. So there is no particular difference between the nature of this connection. So we can say that's bidirected. But when we have directed networks, for example, if Kende follow Chidi, but Chidi necessarily does not have to follow Kende, so that's a directed network. Network tools and visualization tools. So let's look at some of the tools that we use to visualize our network. Some of them are the gephi, which we are going to be using today. Then we have the network X, then iGraph, and so on and so forth. So, but one thing that is common, with these tools is that they help us to visualize our network. And because of this, there are some principles that we always want to look out for. For example, every node should be visible, and it should be able to count the edges. And if you are talking of clusters, for example, or outliers, they should be easily identifiable. So that the way the network is laid out, so that helps you to make whatever inference that you want to make from the network. Network data. How does this data look like? The data that we load into these tools, okay, how do they look like, so that we can be able to get whatever network that we are looking for? So this we have one that is called the edge list. So for the edge list, these are the objects that I talk about. Where my mouse is right now, you have this net A and B connected together. So this shows the edges in that particular network. So you just load those edges right up to the end, and then it gives you the network. And then you also have the adjacency matrix. So for this one, the way the data is all the nodes in the network, they are on the column and also on the rows. So if, for example, you want to say that A is connected to B, so you have in this particular one, now you see A connected to B, you have 1. But if A is not connected to G, you have 0. So A is definitely not connected to itself. So that's how you load the adjacency matrix data for your network. So, but for this training, we are going to be using the edge list data. So let's look at some network metrics. The first one that we are going to be looking at is the degree distribution. So for the degree distribution, what we are simply saying is that how many connections or how many links, okay, do we have for that particular node? So that's for the degree distribution. Then for the density, okay, that one gives us the overall connectedness of a graph, and it doesn't really uh, focus on the nodes, it's focused on the edges. So it's looking at the whole graph as a whole. And then these metrics, the value for these metrics usually range between 0 and 1. So when it's 0, we say that it's not dense at all, and then when it's 1, that means it's as dense as possible. So the next one is the average clustering coefficient. So for the average clustering coefficient, it measures the tendency for a node who share connections in the network to become connected. So what we are saying is we're looking at the triangles there in that particular network, how many of them exist. We want to see how much of them. So that triangle now tells us, it's usually referred to as a triadic closure. It tells us the possibility of us having, this a lot of connections, or the kind of connections that we'll be able to have in the future. Let's look at the network diameter. So for the network diameter, this gives the maximum distance between any pair of node. So that's the network distance. So it gives us an idea of the size or the distance between one extreme to the other extreme of the node in the network. Then the network communities. So usually when we have a subset of nodes in the network, such that every author in the subset has a path to other author, that's what we call the community. So we want to look at how many communities exist in that particular network. So the next set of network metrics that we're going to be looking at is the centrality. So for the centrality, we have the degree centrality. Okay, so this is based on the notion that important nodes have many connections. Then for the closeness centrality, that one is based on the notion that nodes that are important are going to be a short distance away from other nodes. So if we're saying this particular node is important, then it's not too far from other nodes. Then for the betweenness centrality, that's the next one. That one is based on the assumption that nodes that connect other nodes are important nodes. So what are we saying here? We're saying that if a node happens to be bridging a lot of other nodes, connecting them to each other, then we are saying that, okay, it's important. So then the last one, there's so many other ones, but we have just selected this four. For the eigenvector centrality measure or metric, that one tells us, it captures the notion that the more central the neighbors of a node, the more central the node itself. And so that's the one we are even using particularly for this training. So we can use any one. After you have tried this one, you can still try any other metric. Now let's look at some metrics that are social network or social data dependent. We have the one that we call the edge weight. So it's quite similar to what I said earlier concerning the width of the edge. So the edge weight gives us the strength of the relationship between two connected nodes. So I think I explained something like that earlier. Now, the next one is the path length. So the path length also tells us distance between nodes. So if the physical, that's the geographical distance between these objects in this network, if they can also be represented, okay, using this path length. So if they are close, the path length in the network will be shorter than if they are far, then the path length in the network will be longer. Then another one that we have is the connected network. Okay, so a network is connected if each node in the network has a path. Okay, so the idea is that we don't say it's connected if there is a node that is just standing and is not connected to any node. So, well, in reality, a network may be unconnected in its entirety, but if it can have segments, okay, it can have communities or clusters that are connected within themselves. So that sometimes that is what you usually have. Okay, so let's continue. Then we have more metrics on social data. That's when we are talking about a click. For example, what is a click? When I want to discover in our network a click. So what is that? So it's a network in which each node is directly connected by an edge to every other node. Okay, so a kind of cluster. We also sometimes have singletons. So we want to measure a network, a social network, by how much singleton, is existing there. So what is this? Okay, this is an unconnected node, as in it's just standing on its own there. We'll see something like that even in the network that we create in this training. So it's an individual, for example. This usually happens when an individual is not participating in the chat on a social media. So back to our goal. Now that we are done with explaining the fundamental theories, we are going to go back to the goal which we set out, which is a form of marketing research, whereby we want to discover some insights from our network that we create from our social media data. So we are going to go, in order to get the data, like we said, the first thing I want to do is to retrieve the data from whatever social media platform. So in order to do that, in this training, we are going to be using Netlytics to retrieve the data. So to do that, you have to register for Netlytic, and that is quite very easy and straightforward. All you have to do is go to netlytics.org, just like I have right here. Type it in your URL, type it in your search, whatever browser that you are using, and then it will bring you the landing page. But before I go to the landing page, I just want to say that, well, for Netlytics, the data that you can download from it is not just Twitter. You can download Facebook, YouTube, Instagram, and so on and so forth. So that's from whatever platform. But just be sure, because it might be changing, so just be sure which data is available on Netlytics. Just check before you register for it. But I'm quite sure that we have Twitter and Facebook there. Okay, so now when you get to the netlytic.org, okay, just like I have where my mouse is right now, this is what you are going to see. So when you see this page now, you might want to sign in with your Yahoo or your Google account. So just by clicking on this, it will prompt you to select the Google account that you want to use to sign in. So as soon as you do that, you have this interface. So it logs you in, and then this is the interface that you're going to see. So, but before you go around doing some business on it, it's good to click on this tab, About, so that you know what exactly Netlytics can offer you. So if you click on the About, you'll see a lot of instructions about what's data collection and so on and so forth. So one part of the section of the About that I would just like to draw our attention to is that in Netlytics, you have free accounts, which allows you to download, maybe the first year allows you to download 3 free data sets. Then you can upgrade even for free to 5 data sets. But if you want more, you probably have to pay. So this is what, so when you scroll down that page, this is what you are going to see there. So, but before you continue, or before you can even use the free tier to download the data that you need to link Netlytics to your Twitter account, because you want to download it on Twitter. And how do you do that? All you have to do is click on this My Account. And by the time you click on this My Account, you will see something like this. Okay. So when you see something like this, you want to click here. So when you click on Sign In with Twitter, it will prompt you to a page like this. So on this page, you enter your Twitter account. Yeah, that's the name of your Twitter account. and then your password to your Twitter account. And then you click on authorize app. So after that, it automatically links you to it automatically links your Netlytic account to your Twitter account, and you are ready to download your data. So in order to download the data, meaning that we want to collect tweets for our analysis, you need a search string. And in order to get that search string, you want to go to this URL that I have right here. So twitter.com. So you can just type it in your browser, open a new browser and type this particular URL. So once you type this URL, it will bring you to an interface like this. You see this interface on the Twitter account that comes up. So you want to type in the search criteria that we talked about earlier. So we have bank, COVID, Nigeria. So after typing the search criteria, so all the keywords that you're interested, so you should just make sure that you have the rich keywords should definitely be related to the issues that surrounds the research that you want to do by trying to retrieve the data, and also make sure that they are also popular, because if it's not popular, Netlytics will just tell you that you cannot find any tweet that is related on it, and that's your particular download account will just be exhausted quickly like that. So you type in the search criteria. So for this training, we are using bank, COVID, Nigeria. That's the search criteria, but you can easily use another one depending on the problem that you are solving. So after that, you have, if you keep scrolling down, if you keep scrolling down the advanced Twitter search page, you will see this interface, advanced search. So is any language, or if you like, you can put English language depending on the language that you're interested in. But just leave it as any language. Then they probably don't need to alter here. So if you keep scrolling down, these are the interfaces that you will see. So finally, you get to the last one at the bottom of the page. That's the one that has to do with dates. So after the search criteria that you enter, most likely is the date that you now come and put there. So I just left all the other ones as default. So now for the dates, I selected April 1st, 2020 and June 12th, 2020. So that's the period that I want the data, that any tweets that is between that period should be downloaded. So, and then after that, you click on search right here. So when you do that, this is the interface that will come up. So on this interface now, what you're looking for is this. You're looking for this. Okay, this is the search string that you need in Netlytics. So by the time you copy this particular search string, or we call it search query sometimes, that is what we're going to be using when we get back to Netlytics. So, well, maybe I should just say something here, that if you want to do a research, usually for us that we're in the academia that want to do a lot of research using social media data, for your research, for your data set, the data corpus that you are going to be using for the research, for you to get, very valuable insights, it has to be between 10,000 to 50,000, okay? But you can still do a lot with 2,500 that Netlytics is offering you. So most trending topics on Twitter start from 50,000 tweets. So that's when you want to start, making some conclusions based on the data that you retrieve. So now we're back in the Netlytics environment. So holding that search string that we just got now from Twitter, we come back to the Netlytics environment, which is the environment that is displayed to you as soon as you log in. And even if it's not displayed, all you have to do is in your Netlytics environment, click on new data set, and then you have this particular interface, meaning that you want to create a new data set. So if you click on this particular, importing now, you will see this an interface that will come up. That interface is the interface that you're going to put the search string that we just got from the Twitter advanced search. So this is the interface that should come up. So when this interface comes up, in this place, that search string that we got from Twitter, you put it right here, you paste it right here. And then that's in this Twitter search query. Then the data set name will be the name that you want to give your data set when Netlytics has gotten that particular data set for you. So after doing that, you can scroll down on this page, and then you ask it to find the tweets for you. So as soon as it finishes running, okay, this is the interface that you should see. So that's if you're successful, if Netlytics has been able to help you to pull down the data. Like as you can see here, for the search criteria that I put, Netlytics was able to retrieve 485, records or tweets. Sometimes without error anyway. Sometimes Netlytics might return an error and it tell you that it has not been able to retrieve anything, or maybe it's still retrieving. So what possibly must have happened there is that the search criteria that you entered did not have enough tweets for Netlytics to bring out for you. So you might want to change the search criteria to be something that is more popular, or something that you might be able to get tweets coming up. And remember that you have just about maximum of 5 attempts to try the Netlytics for free, of which after that you have to pay to continue trying or to have more tweets retrieved. So please, while you are still practicing, you might want to make that search criteria popular so that you can have something to actually understand the process with. And if you need the data, you can now register with the Netlytic account to be able to retrieve the data for you. So the next thing that we're going to be doing after the Netlytics has retrieved the data for us is that if you click on the My Dataset tab right here, okay, you'll be able to see this interface. So meaning that the Netlytics has been able to, remember the name that you gave for the data set is what you have right here. So meaning that the Netlytics has been able to retrieve the data for you, the tweets, and it has put it inside this particular, data set. So on this page, for example, you can see that it is saying that I've used 1 out of the 3 free data sets that I have been given. I can still get more, up to 5 when I exhaust that. And it is telling us the date that I retrieved. And well, this button, for example, at this point, you might want to download the data, okay, as a CSV file and go and use it maybe on Excel, gephi, or whatever platform that you want to use it. And then Netlytics also allows you to do some form of analysis. So you can just try and explore that first. So we'll just quickly look at that before we now go to the gephi and export the data to gephi, and then see how you can actually do, better graph visualization. So let's click on this bank COVID Nigeria, depending on the name you give your data set anyway, and let's do some analysis in Netlytics before we go to gephi. So by clicking on this bank COVID Nigeria, okay, I'm going to have this interface. But before that, let me just quickly go to the previous interface. So if, for example, remember I told you that you can actually click here to download the data. So if that was the option that you did, this is what you are going to have. So you can see the data in the Excel format. So this is all the columns that Netlytics has been able to retrieve from you concerning those tweets that it was able to get based on the search criteria that you put. So all these columns, they have what they mean. For example, the description of the tweet, the title, the author, and so on and so forth. So you might want to use this to do any analysis that you want. So back to the Netlytics environment. So assuming I clicked on the data set, let me go back to that slide. Assuming I click on this particular data set now, for example, I'm going to have this. So when I have this now, you can see the options that you have here. So you have edit, preview, text analytics, network analytics, and so on and so forth. Let's just try and quickly see what the text analytics would give us. So if you click on text analytics now, you have this you have this interface. Remember, this is the data set. So now on this interface now, you might want to do some text analytics. Maybe it is telling you that it has found some unique, keywords, and there are four posts that you actually have, and it has found some unique keywords. So if you click on this, for example, it will come out, it will give you an answer or interface or results concerning those unique keywords that it has found. But well, the reason why we did not do this live is because it actually takes time. So, but if you click on it, you might want to wait for some time and just leave it and go and do some other things, because it's going to be queued, real time, and then the results will come back, after some time. So, but assuming you have clicked on this particular button now and you wait for some time, okay, you see these results that it will come out for you. So this is the output that you are going to see. So for the output, you will see that the keyword extractor has already done its work, and it has found, can you see here? It has found 9730 unique words from those 485 posts that we saw earlier. So, and well, if you like, you can export this and in a CSV file and go and do more analysis, on another platform, and so on and so forth. And if you like, you can still continue to use Netlytics to be able to do more analysis, maybe like network analysis. But before we go to doing some more network analysis in Netlytics, let's just see what the word cloud looks like. Okay, so if we click on this word cloud button now, we see that we have something like this. So this has created a word cloud of the top 30 words that it found. Now on the previous slide, before I got to this word cloud, is the exported CSV file. So where did this one come from? Back to the interface, that was the output of our text analysis. We can see that if you click on word cloud, that will show you what I just showed you now, the word cloud. But if you click on export CSV, okay, it will give you this particular file. So this is the CSV file that it was able to get, for the keyword analysis and so on and so forth. So if I want to export that and do something with it, just like I said earlier. But if not, you can just click on the word cloud and you get the word cloud output. So we are done with the text analysis tab. That's this tab. Let's now click on this tab and see the network analysis. So for the network analysis in Netlytics, okay, so we have, if you click on that, we see this output that will come out. So it's telling us, that it can get the tags for us, the names and so on and so forth. So in order to do that, we can just click on this particular button. And by the time we click on that, we have this particular output. So you can see that the tiles, that's the tiles, the edges now is 292. Then the unique names, as the names that was found for the network, about 5. So we are talking of the nodes now. Okay, so now with this report that he has given us, we can actually visualize it even in Netlytics before we go to gephi, and see the network by clicking on this. So if we click on this visualize now, so you might want to click on that and see what I'm going to show you the output just in a minute. Then, but before we go to that, we can click on export. And that is actually where we are going. We want to export this network data and want to use it in gephi. Okay, so now for this export, if you click on it, you will see that it will give you an option of how to export the data. So either of these two tabs, whether the export or the visualize, I'm just going to tell us what will happen when we click on them. So if you click on the visualize, this is what you are going to see. So it has visualized that particular graph, the data that I got, from the Twitter, the graph data that I got from the Twitter, it has visualized it, and we can see what it looks like in Netlytics. Then if we click on the export, all right, so it's going to, we are going to have this particular, interface. So for this interface, it's going to tell us what destination do we have in mind. So you want to select on gephi, because that is the one that we want to use. Then it will ask you to say where you want to export the data. You probably put it on your desktop, download, or whatever. So that's what you have. Now that we have been able to export the network data, for example, it has given it the name dynamic. You can decide to give it any other name that you want. So we're going to be looking, I'm going to stop the PowerPoint right now, and I'm going to go to gephi and try and bring in this data that Netlytics has exported for us that is somewhere in our system. Okay. So right now, I am in gephi. So assuming you have installed your gephi, this is and you load it from your desktop or wherever the shortcut is. This is the interface that you have opened for you. So from this interface, you want to open the data that was just exported now from Netlytics. Now, in order to do that, you might want to click on Open Graph. Provided all these ones are not there, click on Open Graph. So I'm just waiting for it to open. So I'm going to look for wherever my graph is. So let's assume that it's probably on the desktop or wherever. Okay, so I'm going to pick it and I'm going to say open. So when it opens, okay, this is what you are going to see. And everything looks in order. So the next thing that I want to do now is to just click on OK. All right. So now I'm waiting for the graph to load. Okay, so it has loaded, and right now is in the data laboratory. So I might want to click on overview to see the graph itself. So I'm waiting for the graph to load. Okay, so the graph has loaded. So this is what you should see. Now that you now have this graph now, you are ready to start working on it in Gephi. But before we do that, we need some plugins in this Gephi environment. So in order to do that, you have installed Gephi before, but let's just try and complete that installation by going to Tools, just like I have here, and you click on Plugins. So I've been able to install most of the plugin, but just in case you just installed Gephi, you might need to install these plugins. So once you go to Tools, just like I did, go to Tools, and then you select Plugins, and you download all available. Most of the plugins I've downloaded it. So, but for your own, you're going to see a lot of plugins that have not been, that have not been downloaded. So you want to select all of them. For me, I've downloaded everything. That's why I'm having this. But for you, you should have a lot of unchecked plugins here. So you just click on all of them, and then you click on install, and then it will, or an update, okay? And then it will install all of them for you, because we are going to be needing some of them to do the work. So now, after that, you can close. So if, for example, you believe that there are some other plugins that is not here, you can check for plugins, actually, new plugins. But right now, I don't have any new one, but you can click on check on plugins, so that if you're just installing Gephi, you should have new plugins, and then you click on it, and then you update everything. Okay, that will give you a lot of things to be able to do. So now, after that, you want to click on close. So let me just quickly say one or two things about these interfaces, but we're not going to be using all of them, but I just want to say one or two things. For example, right here where I have my mouse is the layout, okay? So that layout is where you determine what this graph is going to look like, where you set the layout. They have different types of layouts. Particularly if you have installed those plugins, you will see all those layouts. Then this is where you do the cosmetics, of the graph, the sizes of the edges, nodes, color, and so on and so forth. Then this is the side that you want to run some statistics on this particular graph. And then this is the tab that probably you want to do some filtration and so on and so forth. We're going to be using it just in a minute. So that's where you do that. So let's just interact with the Gephi, and as we interact with it, we'll be using some of these, interfaces that I just explained. Now, the next thing that I want to do with this graph right now is that we want to run some statistics on this graph. So generally, since you might not even know which one is doing which, you can find out what they are doing, and actually in the outputs, whatever they are doing usually comes out. But you can usually what we just do is just run all the statistics, for example, on the graph. So just run them, and by the time you click on each one of them, they'll tell you what exactly they are doing, and even their outputs would also tell you what it is about. So I'm going to run this one. So you can see that the output, this is doing degree distribution, like I explained earlier when we're talking in the theory part. So, and then you can even see, the output, the in degree, the out degree, and so on and so forth. So the average with degree, so you see it there. Then, so I'm just going to run everything. So it's a directed graph, so I'm running that too. And then sometimes it tells you the algorithm that is used to calculate, some of the statistics that you are running. So I'm just going to run everything. Just pay attention to whatever is telling you so that you know what to click. If it's a directed graph, we want to click directed, and so on and so forth. So modularity gives us the communities. So I'm running that. I'm running the page rank too. You might want to find out what that is doing. Clustering coefficient. Remember we talked about average clustering coefficient the other time. Connected components. We also talked about connected components. And so on and so forth. So if there's anyone you missed out and you need it, you can easily come back to run it. There's no problem. So path length, you can see path length is being calculated, and yes, okay. So I think that is what we need for now. So having done that, the next thing now for us to do, based on all these statistics that we have run, we can actually go to the data tab and see the result of all these statistics. And if we are interested, we can export this, and it will tell us where do we want to put it on our system in form of this CSV file. So you can just put it on your desktop, and then you can use it in Excel or any other analysis platform that you intend to use it. So, but for this training, if you want to see how to export to Excel and use it for analysis, calculate correlation, and so on and so forth, you might want to check our training on how to improve employee efficiency, on our YouTube channel. But we are not going to be doing that now. So I'm going to go back to the overview, because our goal for this particular training is to be able to discover influence. And particularly, in order to do that, in this training, we want to use the eigenvector centrality. Okay, so I'm back on the tab now. So let's make this network look a little bit presentable. For example, maybe we're going to be presenting it to the team and so on and so forth. So in order to do that, I will come to the notes tab here, and I'm going to, this is color. Okay, so I might want to click on color, and I might want to click on, of course, it's already on unique. So if I click on this now, let's look for a very attractive color, maybe probably something like this. Okay, so if I click on apply, I should be able to have, you can see that the nodes and the edges have been colored according to what I selected. Now, the next thing that I want to do is that I probably want to maybe give the edges, because the nodes and the edge now, they are the same color. So I might want to give the edge another color. So let me click on edge this time around, and let's pick a contrasting color, maybe like blue or something. Okay. So if I do that and I apply, you can see that the nodes are still pink, but the edges are now blue. So we can see it's looking a little bit more clearer. So the next thing that we might want to do after that is, there's so many things that you can do depending on how you want it to look like. But let's do some ranking. Let's use the size or something to do some ranking. Size, maybe degree or centrality. But since we are particular about using eigenvector to discover the influence of the nodes in this network, let's adjust the sizes of the nodes now using eigenvector centrality. And how do we do that? We come back to nodes here, and we can click ranking. We can click ranking, and it's going to ask us to choose what we want to use to rank. So I'm going to select the eigenvector centrality, and I'm going to select sizes. Okay, sizes. Note that sizes should be selected here. Then note, then ranking. Then you choose your attributes, the eigenvector. Okay, so you have that. So we are leaving at, let it range between 1 to 50. Let's apply and see what that looks like. Okay, so we can see that we are already discovering influence right now. We have seen that this node is particularly, it has a lot of influence. This is the next one to it, and so on and so forth. So we are going to continue. The next thing that we want to do is that we want to be able to do some layouts. Let's run some layouts because they are kind of clustered, and the edges are on top of each other. So let's do some layouts. So if I select, there's so many layouts here that I might want to select, but I'm just going to select this Frenchman Rigaud, and I'm going to run it and see what is going to happen. So by the time you click on run, it keeps on running, and then wherever you want it to stop, you can click on stop. So let's run this. Okay, let me stop. Okay, I think I want to stop. So this looks fairly okay, but you can keep running it depending on whatever you want it to look like. So now I have something like that. Now let's eliminate nodes with only one connection, okay, just to see what this is going to look like. So we want to zero down on that. So we are going to go to, in order to go do that, we are going to go to the filters tab, and under the range, okay, we want to look at, okay, I'm on the filters tab right now. I want to look at under the attributes, I want to look at range, okay? And since I'm particularly interested in the eigenvector, okay, I might want to use that to filter. But like I said, if what we want to do is just eliminate nodes that have only one connection, is the degree that helps us with that connection. So I might just want to drag my degree to the queries tab right now. So let me drag the degree right here. So I have something like that. So if you can see what has happened, you can see what we have here. So if I want those ones that have only that I want to remove those ones that have only one connection, and see what will happen. So I might just come to this place, and if I make this, well, if I want to remove one connection, I might make this 2. But if I want to remove those ones that have 2 or 1 connection, maybe I might just make it 3. So we can see what it will look like. So I have 3 here now. So I can say it should filter. You can see that most of all those 1-1 connections have disappeared, and all I have is the ones that have at least 3 or more connections. So we are saying that, okay, if it's 1, it might probably not be important, but let's just start investigating from those ones that have 3 and above. So after that, now what I want to do now is that I want to be able to run that particular layout again, because it looks as if they are scattered all over the place and they are not showing very well and all that. So let me run this particular layout again and see what will happen. Okay, so we can see that now we have all those ones eliminated and we have the network looking a little bit, compact and presentable. So the next thing that I want to do now is that I want to add labels. I have these networks, I don't know who they are. Particularly, I can see a very influential person here, but I don't know who exactly the person is. So I might want to add the node labels. So you can see that the node labels have come up just by clicking on this particular place. So the next thing that I want to do is I might decide to adjust label so that in case some of the labels are on top of each other and I cannot see their name very well, I can come and adjust label here. So let me stop this so that I can pick something else. Adjust label. I'm looking for adjust label. Okay, label adjust. So I can just run that. Okay, so probably not much, not plenty of them, though there was a little shift, but not plenty of them was on top of each other. But if you have those labels that are plenty and they are on top of each other, that will just make them to be clear so that you can actually see what is going on there. Then the next thing that you want to do now is that you want to adjust, you want to adjust some, you want to preview, okay, sorry, you might want to preview and see what is going on. So in order to do that, you might just click on the preview tab, but we are coming. Before we get to that point, let's see, yeah, I think we can actually preview. Let's see what it looks like on the preview tab. Okay, so that this can look more beautiful. Let's see. So let's click on refresh. Okay. So we can see that, you can see what the graph actually looks like if we are previewing it. Then when you are previewing, you can see that we are not seeing some of the nodes, but you can say it should show node label. So you can see I clicked on show node label right here, and I click on refresh. So it has shown the node label. So you can actually see that this looks more beautiful, and then we can see we can see a big influence right here, and we can see another one here. We can see, so the Eigen vector has helped us to actually, discover the influence that those commenters or those users that they are in the network that have a high influence. You can see this, you can see this, you can see this, you can see this, and so on and so forth. So after doing this, we might want to now export this, probably, using maybe PDF or whatever, can export it and use it on our presentation based on whatever we want to conclude. But let's just go back to our PowerPoint right now, and let's go and conclude the training. Okay, so now remember that the problem that we actually set out to solve was to discover influencers using this social network data that we downloaded, and then, take some valuable actions. So from the graph that we were able to discover just right now, we're able to see that there are some users that, were very prominent, okay? And from there, we can be able to start saying these are the users that people want to listen to, and so on and so forth. We might want to contact them for some marketing purpose and competitive intelligence analysis purpose, and so on and so forth. So, and the data that we actually got, even from the um, gephi, the analysis that we ran, even though we didn't use it in this training, it can be used for a lot of things. And we can see that even though we just pick the eigenvector centrality, we have other centralities there, like the betweenness and all that, that for example, if we want to know who are the commenters or users that form bridges between a lot of other users, such that when they get an information, almost every major community in that network have already gotten that information and they want to target them. So in that sense, we might use the betweenness centrality instead of eigenvector that we used. So this information can be used in so many ways in order to, do whatever we needed to do as a result of the market research that we're carrying out. So if, for example, you export the data, like I was saying earlier, to Excel, you can use it for regression, correlation, and so on and so forth. And that's where we are going to be concluding the discovering of influencers on our social network goal, and using that social network analysis. These are some of the references. Well, we have a training coming soon in September 2020. It's on data science for business success, and it's going to be featuring a lot of problems, business problems for SMEs, for different types of businesses. So these are these are some of the problems that is going to be featuring, and even more, much more than this. If you're interested, you can just call the number that we have here, and please like us, follow us, and leave us comments on our social network platform. Thank you.